So I'm going to do this question here, which I think is quite a good one to demonstrate log laws and why they work, where we have a log with a different base inside of a log, and then we swap around on the other side. And the condition is find log 2x squared. Sweet. So, starting off right off the bat, we can acknowledge that we've got matching bases, right? So even though there's different bases in terms of inside and outside the brackets, if we do one thing to one, if we do something, if we do something to this one, we can probably do the same thing to this one because it's got the same base. Now, what I think the first thing that we should prioritize is getting these things with the same base, because that makes logs a lot easier to work with. And the way we can do that is by using the change of base rule, where it's like log AB equals log CB over log CA. And if you let me, I'll teach you where that comes from, but we don't have to know that for now. Actually, I'll leave this up. So let's just assume this is true. I'm not going to assume really weird properties, but this is one of the ones you said you know. So I don't know where I can put it. Put it up here. So knowing that, we can represent log 8x equals log 2x over log 8. And the reason why we choose 2 as our base here is because this allows us to write this as log base 2x over log base 2 cubed. And then this simplifies to log 2x over 3. We can bring it out the front now, which again, I can show you where that comes from if you let me. And then this equals 1, which again, I can show you where that comes from if you let me. 1 on 3 log 2x. So we know, well not we know, but we've now determined this, right? And we can now apply it, like I said, to both the inside bit there and the outside bit here. So let's do that next. So I'll just chuck this, just chuck this to the side. Log 2 Now, what we can get from this is 3 times both sides. And then just subtract everything over to one side, I think is the easiest way to do it. There could very well be another way, but I don't know of it. So 3 log minus now again, you said you know this property, so I'm just going to use it. If you take this number out in front, you can actually chuck it up there. The reason why is 3x equals, right? But with logs, we get this, and we know that if you add two logs, you multiply them, and then again multiply these. So that 3 out the front we can put as a power of 3 instead. I guess I'll just chuck this to the side as well. Bunch of useless stuff we don't need, or not useless, sorry, but we don't need to show necessarily, but it's good to understand it. Log 2 Now I understand I'm doing a lot of steps here, but I really just want to show every single decision I make and explain why, because otherwise you don't really understand where the approach comes from. And then this becomes log base 2, 1 on 27, log base 2x cubed, now it might seem like we're not going anywhere, but here's where it really helps. We get log base 2, and now because this is subtracting here, it means we divide the terms inside the log if we combine them. So we get 1 on 27 log 2x cubed over log 2x. Alright? So this comes from here, and then this goes underneath. Just to clear that up. So we get this equals 0, and this simplifies because that cancels and becomes a 2, and so we get log 2x squared equals 0. Now, again, I don't know if you understand what a logarithm is, but I'm assuming you do know that we can change. So for A, B, C, log ABC, we can change it to be A to the power of C equals B, right? So knowing that, we can say 2 to the power of 0, oh, wrong color. 2 to the power of 0 equals 1 on 27 log 2x squared, and then 27, 2 to the power of 0 is just 1, right? So 27 times 1 is 27. And if I'm not mistaken, that's just our final answer that we need. So even though it seems like a long process with a lot of steps, obviously a few of these steps you could just skip or not write down very much for. And obviously you don't need to show any of these and where they come from. That was more just for your own sake. But if you just approach the problem with an understanding that you're going to want to make the bases the same and rearrange things and everything, it's pretty straightforward algebra from there, I think, at least. And I don't think you would struggle with the algebra. I think it's more the approach that's the issue. So hopefully this clears things up a little bit.